Hey, super awesome that you're here today. So in the last video, we talked about the project setup for unit testing, and also we wrote a few unit tests together. In this video though, I want to go into much more detail on that. So let's go! Alright, so the thing that we want to test is a simple web service written using Python and Flask. And it is basically just a very simple web service for data ingestion. So it accepts post requests on the path receive, and then it basically just validates the request, does some transformations, and tries to write it to BigQuery. So let's step through the code first. As I said, it's a simple Flask web application with a route pointing to receive. It accepts a post request. We get the data from the request, we do some validation, we ensure that the key important is in the data, else we will raise an exception. Then we will do some transformations where we filter out some not needed keys. And then finally, we will write it into BigQuery. And then, some HTTP status codes are returned based on whether it was a success or the call failed. So on first glance, that looks quite reasonable, right? But there's actually one issue already that I don't like that much. And that issue is that in this case, the concerns are somewhat mixed. So the Flask route method is also responsible for the business logic. And I don't really like that. So I like to have the business logic separated from the HTTP processing logic. So what do I mean by that? I like it better if everything that is concerned about, for example, the HTTP processing, like processing of HTTP headers, processing of the HTTP post body, and HTTP status codes and whatsoever, is separated from the actual business logic. One way to do that is to create a separate class and refactor the content of this method out into a separate class, or you could use functions in a module. So for the sake of this tutorial, I will use a class. And also one thing to mention is that the implementation of all of this is treated more like an example so that I can demonstrate different points in unit testing. It might not be the real implementation that I would pick in a production application. But that being said, let's dive into it. Let's write some unit tests, but first let's refactor that application so that we can test it more easily. So as I said, I want to introduce a new class. So let's create a file for that. Let's call it data receiver. Let's create a constructor and initialize some variables. Data set self D. All right, with that being in place, we can already go ahead and import and we can go ahead and instantiate it. So we pass the parameters. All right, now we have an instance of our data receiver service, and now we need to move all the business logic into that service. Let's do that. So first thing is the check validity part. So for that, we create a new method and call it validity. And it has a parameter data. And for that, we just go ahead and copy the content into here. All right, that was kind of easy. And with this method, we will demonstrate how to handle exceptions in unit testing. The next method is the transformation. So let's call it cleanup data. Cleanup data, self data. All right. Copy that stuff in here. And now we actually also need to return something. Return data. Okay, so you might notice that there is this dictionary call, or rather the call to the dictionary copy constructor or something. So why do I do that? So basically I don't like that methods mutate the parameters that are passed into them. And this is why I need to copy the dictionary first so that I can remove elements from it without actually touching the real dictionary that has been passed into my method. And we will also test that with unit testing. With that in place, there is the last thing that needs to be moved over, and this is the writing to BigQuery. So let's create a method for that as well. Def write self and then we will get this. Here we can now use our class members, data set ID, self table ID, and we need to return the errors. Okay, cool. Now we have extracted everything into the service, but now we also need to use it. So let's do that. Service, check validity, data, the transformations, service, what was it? Cleanup data, but now it also gives us the cleaned data. And the last thing is service write, and that gets the client and it gets the cleaned up data. And for the client, I will just do it like so. And then we also get the errors back. Now we have cleaned up our code and refactored all the business logic out of the actual Flask route. And as you see, it already looks cleaner and it's more understandable what is responsible for what. So now if we have a look at it, basically the Flask part is only responsible for getting the post data and handling the status codes. Now the business logic is actually handled by the service that we have just created. With that in place, we can now very easy test this business logic without even the need of touching the Flask application or the Flask part of this. Because what we really care about for now is the business logic in this application, right? Let's create some unit tests for that. Create a new file and call it test data receiver. Have a typo in here. First, we need to do the import trick to add the source to our lookup path. Sys path append. All right. With that in place, we can import from data receiver, import data receiver. And we can start writing our tests. So let's have a look at the code here. So the first method that we want to test is the check validity method. And what does it do? It checks for the key important and raises an exception whether it is there or whether it's not there. So, and this is exactly what we want to test. We want to have a test that checks that no exception is thrown when the key is there. And we want to check that an exception gets thrown when the key is not there. So let's do that. So let's first test the straightforward way. Test check validity. All right, so we have our class imported. Yeah, I don't care about the data sets right now, so I will just put none in here. And we call it service All right, now we need to call the actual method that we want to test, which is check validity, and it needs a data parameter. All right, we create that one. All right, so as I said, this is the straightforward way. So we want to make sure that no exception gets thrown, which means that data needs to include the key important. So let's add it here. All right, with this in place, that test should already be successful. Let's test it. So let's run Pytest, and we see that one test passed. Cool. All right, now let's check the other thing, that an exception gets thrown if this key is not present. So then we create a new method, test check validity with exception, for example. So we can basically copy the code from here. But now, as I said, we want to check that an exception gets thrown when the key is not there. So we will remove the key from here. Now data is empty. And just to be sure that this test fails and an actual exception gets thrown, let's run it quickly. And yep, test failed. All right, so how do we now go about and check exception handling in unit testing? So for that, you can use a method from Pytest. So first you need to import Pytest, and then you can go here and call Pytest raises. And in our case, it's an assertion error that gets raised. So we check for that. Right. And if you run it now, we see that the test passes. So now we have successfully checked that we are expecting that an exception should occur. And if none exception occurs, the test will fail. And if one occurs, then everything is fine. We can even go as far as checking for the message inside the exception. So let's do that as well. So when we go here, we see that the message of the exception is gna, right? So let's check for that. So we assert that the string value of the exception is equal to gna, right? So now we can run it again, and we see that it still is successful. If the message would be something different, and we would run it again, then it will tell us that the message is different. So let's fix it again. All right, make sure everything is fine. Cool, so this is how you do exception handling testing in Pytest. Now let's have a look at the next method that is here. So check validity, check. Now it's the cleanup data part. So cleanup data is really just a placeholder for any sort of transformation that you do. So that can be used in, for example, machine learning when you do transformations with pandas, or as in this scenario, you have a web service that does some transformations with the data before storing it into some sort of database or returning it to a client or whatever. So just a placeholder for transformations. Let's test that one. So let's go here, def test cleanup data. Right, so basically we can copy this here. All right, so now we call it service cleanup data. And yeah, let's rename that because I want to use the name data later on. Pass it in here. All right, so now let's focus on what the method actually does. So the method accepts data. It checks whether not needed is in the data. If so, it removes it. It checks whether the key temp is in data. If so, it removes it. And if not, it will just leave it and it will return the data back to us. Let's first make sure that those things get actually filtered out. For that, we need to change data so that not needed is in place. And then we also need to make sure that temp is in place, and we want to include also something different. Right? So this data actually returns something, so we assign it as well. And so now the expectation is that the return of, or the return value of this method call will only have this one line in it, because the other two should be filtered out. So let's test that one. So the first thing that we can test is that the length of data items is equal to 1. So that makes sure that there's only one entry left in this dictionary. But now we can't be really sure which entry it is, whether it's the correct one or like one of the others. So we want to be a bit more explicit here. And so we want to check that temp is not in data anymore. And we want to also assert that not needed is not in data anymore. So now let's run it and see whether it's successful. And yes, it is. Nice. With that in place, we know that our logic is basically doing what we think it is doing. But now we also would like to test whether the data actually gets changed that is passed into the method, right? To test that, we can go ahead and basically assert the same thing. I mean, you can also write a new test method for that, but yeah, for time's sake, I will just put it in here. So we want to make sure that the original data is still contains still all three items, and we want to make sure that those still contain the values that we removed inside of our method. We need to also change that one to underscore data. And this basically tests that our method does not mutate the parameters that we pass into it. So let's run that. And we see it works. But what would be if we now would go to the implementation and just comment this line out and basically just replace it with something like that. So if we would run our test now again, you would see that now our test fails because the data gets mutated and that the items actually get removed from the initial data that we pass into our method. So now let's go back and change it to the correct behavior and make sure that everything still works. Nice. With that in place, we also tested the cleanup data part. The last thing to test is the write method. And what I want to show with the write method is how to decouple your implementations and your unit tests from external dependencies. In this case, BigQuery is an external dependency, and in unit testing, you don't want to have external dependencies. You want to only depend on things that are in your control. Because if for whatever reason there is no internet and you cannot make a connection to BigQuery, your test will fail, even though that your code is correct and stuff like that. So you really don't want external dependencies in unit testing. You can introduce external dependencies in other testing principles, like for example, integration testing or end-to-end testing. But in unit testing, you want to get rid of all external dependencies. So how do we do that? One example of that I already showed in the last video, or like one of the last videos, where you can create a dummy class that behaves like the external dependency and just returns mocked data, right? But the way or the how you do it, there are like two different principles. So the one that I really like is that you make the external dependency a parameter to your function or to your class, so that you can stub it out in the test very easy. And also this encourages that your classes are loosely coupled. And yeah, it's generally just a good software design principle. Let's write a test for that. So test write. Okay, cool. Now we also need our service. All right, then we have our service. We call the write method on it. So now it needs a client. We will do that now, just in a minute. And then it needs to get the data passed that it needs to write. Yeah, and also it returns errors. So, okay, what do we do with this client part here? Again, as I said, you could now go ahead and implement like a dummy class, like class dummy BigQuery, and implement like all the stuff in here, and then just go here and use that to call all the methods on it. But yeah, this is kind of like cumbersome because now you need to implement a database method, and whatever is returned by that needs to have a table method, and then also it needs to have a get table method, and it also needs to have an insert rows JSON method, and so on. You would need to kind of like implement mocked versions for those methods in your dummy class, which you can do. And in simple scenarios, it's also might be a feasible way. But in this case, I want to show a different way since I already showed this way in one of the other videos. So how do we go about this? So first of all, we remove this dummy class here, and we want to use mocks. And mocks are basically also dummy classes, but they get generated for you, not by you. And then you can specify methods on those mocks, and you can also specify what, for example, the return values of those virtual kind of imaginary methods are. So first of all, we need to import the mocks. So for this, we use from unittest mock import mock. So unittest is a standard library in Python, or is included in the standard library in Python. So you can always use that, and it works really well together with Pytest. Now let's go ahead and create a mock. So now we have created a mock basically, and we can pass it as our client. So now we also want to specify a method and also its return value, because whenever we don't specify anything, then it just kind of like ignores it and treats it in a way that it's there but does not return anything. That's why we don't really need to specify methods for the dataset or table or whatever, because yeah, we don't really care about them, because yeah, they will just be successful but don't return anything. So here, the only method that we care about is the insert rows JSON method, because that one is actually part of our return value. And so we want to influence the return value of our method. And to do that, we can use the mock, and then we say insert rows JSON. This way we tell it that there is this method, and now we can also tell it the return value of that method should be an empty array or an empty list. This basically means that errors now should be an empty list, which indicates that there are no errors. So we can assert for that and say that there is assert no errors. All right, so when we go ahead and execute it, then we see everything passed and everything works as intended. So now, if there would have been an error, for example, that one would now be returned from our write method. We can test that behavior. We will mock all of the BigQuery stuff because we are not interested in testing the behavior of the BigQuery client, because I'm quite sure that Google went ahead and already tested that. So we only care about testing the behavior that we add. And since in this write method, there is not much behavior that we added besides returning the errors that occurred, this is basically the only thing that we can test. But it's also not about what we test in this specific method, but it's about how to get rid of external dependencies. And so here I showed you one way, or one new way, to get rid of external dependencies by using the mock class from the unittest standard library class method module. Yeah, so this is how you can do it. But there's also another way. And yeah, I will talk about it now. And to be honest, I like this way better than the one that I'm gonna talk about now, because that one is often referred as monkey patching. And monkey patching is basically a way to get rid of hard-coded dependencies. So what do I mean by that? In our implementation, I made a client a parameter to the write method so that I can actually replace it with a mock implementation. But what if there was no client parameter, and instead we would have something like and we would have something like this. Right? So in this way, there is no way to replace this call to the BigQuery client because it's basically hard-coded into this class. Wait, I add the import quickly. What is it? From, what is it? Google Cloud import BigQuery or something. Yes, looks good. How would we go about mocking this one out? Let's go back to the test. Let's copy this. Good. And let's comment that one out. So another way to do it is using the patch method or decorator. So we imported from also unittest mock, and now we can use it here and say patch. And with patch, you want to now provide the complete path to the class that you want to patch out. So in our case, it's Google Cloud BigQuery client. And then it gets passed into here. So what this does is basically it goes ahead, and whenever this class is instantiated, it gets mocked out, and it actually uses a mock, and this mock gets passed now to your test method. So with this in place, I can remove that one here because that is basically now our mock, and I need to instantiate it, and then I can do basically the exact same thing. And let me also fix that one. And now basically it should behave the exact same way as it did before. So if I run it now, oh, no, actually it failed. Yeah, because I forgot to change the actual code, I guess. So that one is not needed anymore. And then in the test, that also does not need to have the client here anymore. So let's run it again. Yeah, so everything passed as you see. And again, I mean, it's possible to use this patch method or this patch decorator, but I rather would not use it. I would rather make sure that my code is written in a way where I can pass the external dependencies as parameters to either the constructor of the class or to a function or method, so that it can be more easily switched up in tests. And also if further down the road you notice that, okay, I don't only want to write to BigQuery, but I also want to write to, I don't know, AWS or to a PostgreSQL database or whatever. Then you could also just create a new client for that, have it fulfill the specific interface, and then you could just drop in the replacement for that without needing to mess with the hard-coded stuff. All right, so this is basically it for testing the business logic of this web service. And as you've seen, we only focused on the business logic. So we did not touch Flask at all, right? Because Flask is the HTTP layer and is rather tested using things like an integration test where you use some sort of client library to make HTTP calls to the client and check whether the responses are the ones that are, that you specified. Flask also has a built-in testing support, so you can check out the documentation for that, but that would be too much for this tutorial. So here I really wanted to focus on how I would structure such a Flask web service and how to test the business logic of it using unit testing. I hope that you've seen that it's not that hard and that unit testing really helps you to define a sane interface to your classes and to make you really think about external dependencies and things like that. That being said, thank you very much for watching. And yeah, don't forget to go completely insane on that like button, hit the subscribe button, and also maybe consider leaving a comment down below. Would be super, super awesome. So thank you very much and see you in the next one.